Welcome back. So this series right here, I'm talking a lot about test-driven development, about the DB context, and I'm kind of combining those. And I kind of came up with this, I found this page right here on Microsoft. Go and read it if you have the time. It's a great page just to kind of do a quick read. It's about testing code that uses EF Core, right? And that's what we're doing right now and how we can test it. Now, as you start going through this, they have a lot of great information that you can go and read, and they have different approaches. You can actually do a production database system, so you can test directly against your MS SQL database. That would, in my mind, be an integration test, and I also think that's what Microsoft describes themselves right here. The second step could be doing it with an SQLite. The MS SQL is a bigger system, so it'll take a bit more time to run each test, whereas SQLite is faster for mobile use normally, right? So it's a fast, small database, very compact, very easy to reuse, recreate, so it'll be faster integration testing. And then they move forward. There's also the in-memory database. Now this is pretty exciting. That's just building the database in memory on your local computer. So again, it's extremely fast, faster than the SQLite, but still there are some problems with this. All of this is integration testing and it's great, but if I did my integration testing against the in-memory database, you'd get some problems later on. And they actually write that themselves right here. It is not a relational database. So it might seem that my integration test was working perfectly with the in-memory database, but at some point later on when I tried to deploy this, it would fail. Why? Well, it would fail because it's not a relational database. And that means that when I try to deploy this to a real MS SQL database, later on, the same repository, the same DB context, I just changed from being an in-memory database to being a MS SQL database. I'll show you this later how to do it. Then I would actually fail all of a sudden. So all of a sudden my production would fail, boom, where it actually worked locally on my machine. And that's one of the problems you're facing if you don't do this right. It might seem that things are running great, but if you don't do this the right way, you'll end up everything looks fine locally, but as soon as you work with production, it'll fail. And that means then you'll start doing some crazy half production, half local work, and that just doesn't make any sense. And again, my focus right here was doing test-driven development and unit testing for kind of proving that things would work, not from the point of view of the different database types. You might still have errors there. That'll be an integration test. We'll talk about that later. But for the point of view that I want to be blazing fast when I'm doing unit testing and test-driven development. I don't want to kind of be bound to any specific database, not even an in-memory database. I want to be free as much as possible, and then I can make integration tests directly against SQLite if it was locally, or against an SQL server actually if it was a real environment. So I would probably use LocalDB to do the unit testing. But again, integration testing is a lot slower to run than your local unit tests. So again, we want to go to the final step, which is to talk about unit testing. And here they have some pretty annoying things in their text. Let's try and read them. So it says pretty much, you should not use mocks, right? It pretty much, don't do it, right? It says, you should not try to mock the DB context. We just did that. You should not mock the iQueryable. We're going to do that because it's cumbersome, it's hard to do, and it's fragile. Now, I don't feel that that's the case with the tests I'm going to write, because I'm not going to try and test that the database is correctly integrated. I just want to test again that when I'm doing something, it should place it in the change tracker, which is a local version of what is going to be put in the database later. Okay? And if that works as I expect, then if the entity framework core works as it should, it would figure out and actually save the data correctly no matter what database I was using in the end. Now I know that was kind of a tough talk right there and a lot of things, but again, go and read this article about all of this, and there's actually a lot of great information in here. And trust me, I don't think any of this is wrong. I'm just going to focus on the final step right here, and I'm going to try, even though they say you shouldn't do this because it's cumbersome. I don't think it's fragile. It's difficult and cumbersome, fair enough, but I'm going to do it anyway. Now, I'm not going to do it from scratch because there are a lot of guides out there where they make a small class that can help you, a small helper. Go and use it if you want to, but I found this GitHub repo right here. I talked about it earlier, where he kind of went in for us and actually tried to do a mock setup using mock, M-O-Q, like we're using, and then kind of made an extension of that called the Entity Framework Core. Now, this great tool right here can help us create virtual DB sets just by doing easy things like this. You create a list you want, you say, I want to set up the mock and I want to return that list right here. That's how simple it should actually be. So we're going to try and use that And then we're going to try and use this setup to try and prove that when I call the add on the context, when it's done, it's actually added in our system as well. So that was a lot of explanation, and next lesson we're going to try and do it in our actual code. So, see you next time, have fun.